Mr. Rasmussen, we had a lab yesterday, lab 10. It was finding, the name of it was counting by measuring mass. And what you were to do, you had three substances. You had water, you had baking soda, and you had salt. And you had to take a level teaspoon, that's why I had the rulers. A level teaspoon, drop it into a cup. You should have already massed the cup so you knew how much it was, see how much went up. You record that in your data. You needed the mass of water, sodium chloride, and sodium bicarbonate. Okay, and then the next thing you had to do is, based on the chemical formula, you had to come up with the molar mass for that. All right, for water, it's 18 because you got 2 hydrogens, 1 oxygen, 2 hydrogens and 1 oxygen at 16. For salt, sodium's 23 and chlorine's 35.5, so you should have had 58.5. I'd have taken 58 rounded. This one you had sodium at 23, hydrogen at 1, carbon at 12, and then 3 oxygens at 16 for 48. And that came up to 84 grams. Now, you have to convert that into moles using that molar mass. Stop it right there. I measured out a teaspoonful right up here. Look up here with me. Up here, right up here. This. I need you looking at this. Are you getting this?
Yeah.
All right, 6.2 grams of water, and I know there are 18 grams in the molar mass, so I know 1 mole's 18 grams. This is a conversion factor. Does it eliminate the grams? Yes, and it leaves you with moles, and you come out with 0.3 moles. Stop it. Okay, so once you got your moles, once you have your moles right over here, 0.3 moles, then you need to figure out how many moles, that's the moles of the compound, you need to figure out the moles of each element. Well, you got 2 hydrogens in there, so you got 2 moles of hydrogen for every 1 mole of oxygen to make water. So instead of 0.3, you're going to have a 0.6 moles of hydrogen. All right, now with that, you're going to use that molar count, look right here, that molar count, and you're going to use a conversion factor that puts it into representative particles. That's what your final question is. Representative particles. How many atoms are you going to end up with? Well, you just use 6.02 times 10 to the 23rd, which is exactly right, Avogadro's number. And you put them, it's 1 mole down here, so do your moles cancel out? Say, yeah. All right, and then you got 0.68 times, and that comes out to something, who cares? You got how this is done, it wasn't that hard. And then you needed to tell me, which one did we have more moles of in that 1 teaspoon, which was water, and which one did we have more particles of, which was water. All right, I hope you get this. And if you're still saying, I don't understand, please work out a specific of what you don't understand and come talk to me before or after school. I'll be glad to help you out here.